So GAdmin is the administrative interface to Kinetica. It's a web interface, and it lets you do pretty much all the things you would expect out of a admin interface. You've got a nice little overview of your cluster. You can start and stop the database, but most importantly, you can take a look at your list of tables. So speaking of WKT, let's go into a table I have here that is a table of all the states and their boundaries. So I've got state shapes here and some other attributes, and you'll see here the shape is stored under a column named WKT. It doesn't need to be called that, but what's important is you specify the subtype of the string column as WKT. So when you have a table set up and you're putting a geometry column in there, you're going to want the type to be string, and you're going to want the subtype to be WKT. Unless you do that, Kinetica will not know that that's a special column holding geometry, and it won't offer you this link over here, which is the first way I'm going to show you to view WMS. So by default, we start rendering in heat map mode, and I'll get into that in a little bit. But let me just show you what this data actually looks like. I'm going to switch to feature. When we talk about feature and heat map, when you're talking about shapes, such as state boundaries or lines, those are geo features, so we want to render those features. And as you can see, that data set is rendered, and I can pan and zoom. And in fact, when I click on one of these things, I'll even get the metadata for that record.
So how does that interaction with the WMS work when you're clicking on the map like that?
Good question. So since this is WMS, this is actually just an image, and I don't have the individual shapes on the client side. But you can see when I click on it, it kind of seems like I do, because it highlights the shape and it gives me the data. What's actually happening here is when I click on it, I'm sending Kinetica my click location, and I'm asking it to return all the data under that location. So very quickly, there's a geofilter run where it finds the data by radius of my click point, returns that data to me. I then render that data on the map and color it a little bit differently. All this happens very quickly, and it kind of gives the impression that you're dealing with a client-side application. So that's some of the tricks we use to make WMS a little more interactive. So we saw the feature renderer there. So features are good for, the feature renderer is good for rendering points, rendering specific shapes, rendering data at a very low zoom level where you're looking at a small amount of data. But if we look at feature rendering on a very large data set where there's a lot of dense data, it just looks like a blob, right? You're just seeing one color. It's not really telling you much. Sure, if you zoom down, it makes sense to see features. You're seeing points, but at a very high zoom level, a heat map tells you a little more about the story. So normally we'll start our rendering out in GAdmin in heat map by default, because we're assuming you're looking at a large data set. And here, by using the heat map, you can kind of see where the intensity of the data is, where the more of the data is on the map by looking at the intensity of the color. So that's what a heat map looks like. And finally, there's a type of geospatial data that's very commonly used in Kinetica. It's called a track. So if you think of a track, it represents any kind of moving data on a map. And in order to represent moving data, you need a few things. You need the point, and you need a time associated with that point. Because then over time, you will see the movement of that data. So in order to have a track in Kinetica, you need a longitude, a latitude, a timestamp, and some way to group it together. So if you think of a plane traveling, which is what this is, it's a table of flights. Using the ID of the flight or any kind of unique ID that's going to group the data coming from that object moving across. That is one of the required fields called track ID. And then you've got your X, your Y, and your timestamp. And show you what that looks like. So again, when you're looking at a large data set in heat maps, you kind of almost instantly get some insight. So since this is flight data, you can see where these points are kind of showing up. These are the busiest airports where flights are taking off and landing. But if we look at features here, you'll see as I dig in, it's a lot of flights, but these are actually tracks. So you've got points connected to other points over time.
That's all being rendered super fast.
Super fast, yeah. Again, that's the power of Kinetica, the GPU accelerated visualization engine here. I mean, I'm zooming in, and we're dealing with 1 million records here that it's filtering in less than a second, easily. So that's your probably the easiest way to kind of visualize data. So this is a good way when you're loading data. At the Postal Service, we have these refresh jobs, and as we're loading the data, we can pull up the map like this, and we'll see the data kind of loading from East Coast all the way across. So we can get an idea of how much of that table has loaded just by looking at this geospatial view. Then we go into a more colorful demonstration of our geospatial capabilities here by going into Reveal. So Reveal is Kinetica's out-of-the-box dashboarding application. And I have set up a dashboard here. This is actually one of our out-of-the-box dashboards that you can download and deploy automatically. So this is New York City taxi data. And what you're looking at here is just a couple of aggregates. Here we have the vendor type. Here we have the type of payment, the number of passengers, the timeline, and of course the points of this taxi data here. So again, you can see I'm using a heat map right now. If I switch over to points, you'll see everything becomes one color, and it's going to render the individual points. As I zoom in, I can see those points. There's a little bit of styling here. I've got it set to automatically size, but I can take over the sizing, and I can change the color. So you can see playing around with geospatial data in Reveal can be a lot of fun. You find the perfect look that you're going for, and you can copy it into your custom application. We've got feature rendering here. We've got heat map rendering here. One of the more interesting rendering types that we have is called class break. So if you think of the WMS layer as one image, if you want to do a little bit of data differentiation in that image, it's possible using class break rendering. So what class break rendering does is it lets you style classes of data uniquely. So in one image, you can represent several types of data. So to give you a quick example, what I'm doing is I'm generating intervals for the passenger count in this New York City taxi data. And this generator, again, is built into Reveal. So you can come in here, play with this, get your data looking the way you want, and then export it into your custom application. So here what Kinetica did was split the passenger count into 3 equal intervals. So we have passenger count 0 to 2 as the purple color, 2 to 4 as the lime color, and 4 to 6.02, I guess, is the max value we have in the database as this maroon color. And it's also uniquely setting the point shapes And I'll go ahead and make these just a little bigger here. All right. So now looking at that data, now remember this is just one image and we're representing 3 different types of passenger count in one image here. So you can see easy to tell the 1 to 2 passenger versus 4 to 6, and then, or no, wait, 1 to 2, 2 to 4, and then 4 to 6, there's a few of them here. So a very cool way to kind of differentiate. Yep.
So yeah, so as a user of this, and if you've got a ton of data at scale, this is, you know, a much easier way to filter through all your data really fast and make sense of it all, right?
Definitely. So you know, you could do this type of filtering by creating 3 separate layers and piling them on top of each other, but that's obviously going to take a performance hit compared to using this class break rendering in 1 layer and letting Kinetica do all the work for you. But yeah, there's some very cool use cases, especially when talking about heat maps. There's some very cool use cases for that that I've personally worked on. So one of the more recent use cases, actually the data kind of look like this. The Postal Service is deploying out parcel lockers for locations where mail is frequently not accepted. So, you know, imagine a driver kind of going up to the door, person's not there to pick up their package, and now they have to bring this package back. So places where that happens a lot, it makes sense to have these parcel lockers. So we created a heat map of the failed delivery events, and, you know, assuming it kind of looks like that, they can really get into the areas where putting a parcel locker will give them the greatest efficiency and cost savings. So it's a nice little realistic use case that we were able to provide some assistance with using the heat mapping. And then finally, you know, Reveal is a fun way to play with the data, but of course, we're probably going to want to use this with some custom development. So here I have our states table rendered in a application that consists of a open layers map. Just a open layers map, there's not much going on. I just wanted to show you how quickly you can get Kinetica into a custom application. There's about 100 lines of code. Here's my map in HTML. I'm creating a base map layer using OpenStreetMap. This is the Kinetica layer. This is about all the code that you need to add WMS inside of Kinetica. So here you can see this is my Kinetica endpoint that I'm running in Docker. I'm setting some of the required parameters here, and I'm telling it to render the states table. And just like that, we have this.